Okay, so we will start with vectors. Mm, am I audible? Can you just say yes or no in chat? Okay, like in case if you are having any doubt, you can stop me at that point only. Okay, because I don't think there are many students in our class, so you can stop me at any point. Okay, so we will start with vectors. So first, let's understand what is physical quantity. Okay, so a physical quantity is any property of material or system that can be measured or calculated, and it is used to describe physical phenomena. Okay, so it is any property of material or system that can be measured or calculated. That is the first thing. And second is it is used to describe physical phenomena. And physical quantities are expressed in terms of numerical values and appropriate units. So here we have, it is like, let's say it is written as 10 meter per second. So here it is representing speed. Okay, we'll say speed because we do not know the direction. So speed is here a physical quantity, and it is used to first of all we can measure the speed of different objects, or you can calculate the speed of different objects. And as told, it is used to describe the motion, used to describe motion of an object. So therefore speed is a physical quantity, and it is expressed as numerical value. So here 10 is numerical value, and meter per second is the appropriate unit for speed. So this is the definition of physical quantity. So let's see the type of physical quantities. So first we have fundamental quantities. Okay, so these are the basic physical quantities that cannot be defined in terms of other quantities, and they form the foundation of all other derived quantities. So basically these quantities here, as you have seen here, speed, to represent speed we need the unit of length, we need unit of time. Whereas if you want to measure length, we simply measure it as in meter or any other units. So it is not dependent on any other physical quantity for measurement. Similarly, mass, it is also not dependent on any other physical quantity for measurement. So therefore these quantities are known as fundamental quantities, and basically they form foundation of all other derived quantities. So let's see the derived quantities. So these quantities are derived from fundamental quantities through mathematical relationship. So as we have seen, speed is basically distance upon speed is distance upon time. So here distance is basically length, is a fundamental quantity. Time is also a fundamental quantity. So the unit of distance is, or length is meter, or unit of time is second. So we got the speed as distance upon time, and its unit is meter per second. So we have basically derived speed from two fundamental quantities, which are distance and time. Whereas these fundamental quantity don't require any other physical quantity for its definition or its derivation. Okay, so this is different between fundamental and derived quantities. So here we have one more example, which is force. So force is also a derived quantities because it is the multiplication of mass into acceleration. So here mass is one of the, actually here mass is fundamental quantity, whereas acceleration is again one of the derived quantity. So what is acceleration? Acceleration is rate of change of velocity. So here velocity is again a derived quantity. So derived quantities, like these derived quantities are formed through some mathematical like these derived quantities are basically derived from fundamental quantities through some mathematical relationship. So this is the classification of physical quantities. So first we have seen a physical quantity is any property of material or system that can be measured or calculated, and it is used to describe physical phenomena. And basically these physical quantities we have classified them as fundamental quantities and derived quantities. Okay, so let's see another classification of physical quantities. So one second. Okay, so let's see another classification of physical quantity, and which is scalars and vectors. There is one more type, which is tensor, and since it is not in our syllabus, we will not go into it. So we will focus our attention only on scalars and vectors. So scalars are basically a physical quantity that has only magnitude and they do not have direction. Okay, so physical quantity that has only magnitude but no direction is known as scalar. Okay, and scalar quantities are represented by a single numerical value and unit. Okay, so here we have mass. So mass is represented at single numerical value 5 and its unit, which is kg. Also you can write like mass as m is equal to 5 kg. So what you are using is one single numerical value and a unit. Now we will see the vectors. So vectors are basically a physical quantity that has both magnitude and direction. Okay, so in scalars has only magnitude, whereas vectors has both magnitude and direction, and it is represented by arrow. So first of all, like if you have some vector quantity, like let's say velocity. So here we have, so what in scalar what we have seen, we use single numerical value and unit, whereas here in vector what we are writing it as 10 meter per second. So we have numerical value, we have unit, and here it is showing 10 meters per second east. So it is showing the direction. So that is one more addition in vectors apart from compared to the scalars. So here 10 meter per second, let's say this is the distance which is showing 5, and let's say this is 10. So 10 meter, and this is the graph of velocity. So here 10 meter per second will be like, it can be represented as a arrow with magnitude 10. So magnitude 10 is basically the length of this arrow is length of the arrow is basically equal to magnitude. Okay, and if you have this arrow, this part is known as head of this arrow, and this part end is known as tail of the arrow. So this head basically shows direction of a vector. So since this head is pointing towards its east, so it and the magnitude of this arrow is 10. So this is basically showing us velocity of 10, yeah, let's say 10 meter per second. Unit is meter per second. So 10 meter per second east. So one more thing about vectors, like apart from magnitude and direction, vectors must follow the law of vector addition, and then only we will call them as vectors. Otherwise, we won't them call as a vector, even if they have magnitude, direction. But if they are not following the law of vector addition, we will not consider them as vectors. Like a physical quantity will not be considered as a vector if it does not follow the law of vector addition. So this point you should note it down. Let's see the scalar addition. Okay, so you know that the mass of first object is, let's say this is m1 is equal to 5 kg, m2 is equal to 5 kg. So the total mass is like 5 plus 10 is equal to 15 kg. Now you if you keep both of them side by side, like this is 5 kg and this has 10 kg, then also total mass is will be like 15 kg. So this is how you add two quantity, means two scalar quantity. Of course both are mass here, so both must have same unit. So this is how you uh, carry out the addition of scalar quantities. So but like if you have one object, let's say you have this object, you are applying force of 10 newtons on this object, and you have applied one more force of 5 newtons, and in another case you have applied force of 10 newton from on left side of the left face of this object, and force of 5 newton on right face. So in this case the total force is acting, let's say this is right, this side is right, and this is left. So net force here is basically 15 newton towards right. Whereas if you see this case, in this case net force is 5 newton towards right. So this is because in vector addition, the direction. So here the head of this arrow is showing the direction, since it is pointing towards right. Here the head of this force pointing towards left. So here the direction of vector plays role in their addition. Whereas in scalar quantities, it does not matter. Like in scalar, if in scalar quantities, like if you have a road of 5 kilometer from A to B, and road of mm, 4 kilometer from B to C. Sorry, road of uh, 4 kilometer from A to B, and road of 3 kilometer from B to C. So from going from A to B to C, the total distance will be 4 plus 3 equal to 7 kilometer. See, it is kilometer, sorry, 7 kilometer. On the other hand, if you want to find the displacement, which is a vector quantity, so let's say you have this was 4, this was 3, here A, B, C. Then this displacement will be the shortest path traveled and it will be 5 kilometer. And here this displacement will always be the shortest path and it the direction of this displacement will be from initial position towards final position, which is C. So in vector addition, basically the direction of vector plays role, and here the phi is basically the resultant that we will show in our class, like how we have reached to phi, how we have um, how the resultant is 5 for this. So as I told, vector is represented by arrow. So this is the representation of vector, where this arrowhead is, this part is basically head, and here you have a tail, and the total length of this vector is basically showing the magnitude of the vector. Okay, we will see one of the property of a vector. So as we have discussed, vector has magnitude, vector has magnitude and direction. Okay, and the magnitude of the vector is represented by length of a vector. These things we have seen in earlier. Okay, so let's say you have a vector A which is making angle, let's say theta, with positive x-axis. Let's say it is making angle theta with positive x-axis. So no matter where you move this vector, if, and let's say its length is L, it is having a length of if it is having length L. So no matter where you move this vector, if it is pointing towards same direction, like if it is making same angle theta with positive x-axis and it is having same length, then these vectors are same. So if even if you call this vector as B, this B is same as vector A here. Let's say this was earlier vector A. Since both are pointing towards same direction, both are having same length, and therefore these are same vector, and therefore you can move vector anywhere you want in coordinate axis. Now let's see the angle between two vectors. So to measure the angle between two vectors, either the head of one vector should meet with head of other vector, or tail of one vector should meet or match with tail of other vector. So here, let's say you have a vector A and vector B. So in this case, let's say the angle is 30 degree, and we can say this as the angle between these vectors because the heads of these two vectors are meeting. And there is, let's consider another case. Okay, there is vector C and vector D, and let's say the angle is 10 degree. So since the tail of one vector is meeting or meeting with tail of another vector, we can say that this angle is 10 degrees. Okay, but consider a case. Okay, so let's say you have vector A and vector B. Now let's say this angle is 120 degree. So if someone asks what is the angle between these two vectors, so this angle cannot be 120 degree because the head of either head or tail of these vectors are not matching. So what you will do is you will shift one of these vector. So either you can, I will just draw it using PC. So in first case, we have moved vector A such that it has reached to the tail of vector A has reached to the tail of vector B. So both tails are matching now. And since this angle was 120 degree, this angle is 60 degree. And therefore the angle between these two vector is 60 degree. Similar thing you can do, like here we have moved this vector B to the so that it's tail touching the tail of vector A. But earlier the system was like this. So you can move vector A so that it will touch the tail of vector A will touch the tail of vector B. So both things are possible. Okay. So as we have seen in this property, like if vector is pointing towards same direction and has same length, then we can move it anywhere in plane or a space, and it will remain same. So here we have seen the angle between two vectors. Okay, just 2 minutes. In 2 minutes, we'll start the resolution of a vector. Do you have any questions in previous part? Just say yes or no in chat so I can proceed further. Okay. So you should always remember, like when you are measuring the angle between two vectors, either its tail should match the tail of other vector or their heads should match. Okay. So now we will start with resolution of a vector. So let's say we have a vector again. We have a vector A So, and let's say this is a x-axis, positive x-axis. This is positive y-axis, and this vector is making angle theta against positive x-axis. So we use basically the Pythagoras, basically right angle triangle for resolution of this vector. So if this vector is basically the hypotenuse of this right angle triangle and this angle is theta, then its uh, resolved part along positive axis x-axis is, let's say it is vector x, and resolved part along positive y-axis is basically uh, vector y. So from Pythagoras theorem, you know that like sine theta is equal to opposite side upon hypotenuse. So it will be basically y divided by vector a, and cos theta will be adjacent upon hypotenuse. So it will be like x divided by a. So so the component of vector a along x-axis is basically given here as x bar or x arrow, and it is a cos theta. Okay, so we are using basically simple Pythagoras theorem for, first of all, for finding the component of this given vector along x and y direction. So here component of a along x direction is a cos theta, whereas component of a along y direction is a sin theta. So this is how we uh, find out the, or we resolve the given vector. Okay, so let's see some example of vector resolution. So So as you can see in vectors, the trigonometry plays a very important role, and that is why the basic trigonometry class was important in vectors, and it will be important in other part of physics also. So you should have some understanding about mathematics before you start learning physics. So let's say we have this vector. This is vector A, and it is making angle 45 degree with positive x-axis. So if we have to find out its component along x-axis, so x along x-axis is, its component is x bar is basically a bar cos theta. So here theta is equal to 45 degree. So cos 45 is 1 upon root 2. So the x component or of this vector a is basically a by root 2. Similarly, y component can be found out as a sine theta. Again, for theta equal to 45, sine theta is equal to, for theta is equal to 45, sine theta is equal to 1 by root 2, and therefore the resolved component along y direction is also a upon root 2. Now you can take like plenty of example like that. In exam also there is possibility that question may come from this part. So let's say now this, let's say we have vector b. This vector b is making angle 60 degree along with positive x-axis. So again, we can find out its component in similar fashion. Like x component will be a cos theta, sorry, b cos theta. So here theta is 60. So since theta is 60, cos theta is 1 by 2. Therefore, x component here is b by 2. Similarly, y component can be find out as y component is b sine theta. So it can be given as, so sine 60 is basically for theta equal to 60. Sine theta is root 3 by 2, and therefore y component of this vector b is b root 3 by 2 into b. Okay, so just if you want to resolve any vector, you should have the knowledge of basic trigonometry. Therefore the table of uh, sine theta, cos theta, and all other trigonometric ratios must be known to you. Or okay, one more special case in this problem is, let's say you have, let's say this angle is 37 degree. So this can come because this is one of the special case. So when this in right angle triangle, when this one of the angle is 37 degree, and if you see, consider the length of this vector or length of this hypotenuse is 1, then the opposite side of this 37 degree will be 0.6 and adjacent side is 0.8. So you should remember this value, like for 37, 53 and 90 degree triangle, the if hypotenuse is 1, the side opposite to 37 degrees is 0.6, and therefore if let's say if this vector is vector a, then its x component is basically 0.8 a and y component is basically 0.6 a. So and in the exam they can reverse this question, like they can keep this as a 53. So if they keep this angle as 53, then it will our answers will be reversed, and x component will be 0.6 a and y component will be 0.8 a. So this is a special case of a triangle which also you should like keep in your mind before going to exam or before solving the questions. So let's see what are unit vectors. So vectors with magnitude of 1 and they are used to give direction. So unit vectors are vectors with magnitude of 1. So their magnitude is always 1. As it is showing unit vector, you should keep it in your mind that their magnitude is always 1. And second thing is they are used to give directions to a vector. So let's say we have coordinate system like x, y, and z. So we use like unit vectors like I, wait, j, k. So these unit vectors have cap over them, and let's say generally uh, I is used uh, to I is used to represent x-axis, j is generally used to represent y-axis, and k is generally used to represent z-axis. So Basically the magnitude of this I unit vector is 1, magnitude of j unit vector is 1, and also the magnitude of k is also 1, whereas I unit vector is pointing in x direction, positive x direction, or you can say j is pointing in y direction and k is pointing in z direction. So let's say if we have a vector, let's consider a plane. Let's say this is positive x, this is positive y, and we have some vector a. So the vector a can be represented as, so first of all we can resolve this vector a along both x as well as y direction. Okay, so this is, let's say this is resolution in y, resolution of a in y direction, this is resolution of a in x direction. So this vector a can be represented as, let's say, x I plus y j. So here x is the magnitude of this vector, x vector, and I is basically representing the uh, I is basically, as I told, it is showing the direction of positive x, and j is showing direction of positive y. So here I is a unit vector in x direction, j is unit vector in y direction, and x is the magnitude of a's component in x direction, and y is magnitude of a component in y direction. So this is how we can represent a vector using unit vectors such as I and j, where I and j are used to represent direction, whereas x and y are used to show the magnitude. Just give me a minute, okay? I'll start in 1 minute. Do you have any questions in this unit vector part, like how for what is the purpose of this unit vectors? And so So basically, we can see if we are resolving this a vector along x and y direction, you can simply write it as x, a as x vector plus y vector, whereas here the x vector, because you can move this y vector here from this property of vectors we have studied, you can move this y vector to this point and you can simply write this a vector as addition of x vector and y vector. Now for, since uh, means I is basically unit vector in x direction, so unit vector is having magnitude 1, so you can represent this x vector as x as a magnitude of x into I unit vector, and you can represent this y as magnitude of y into j, or since it is a single, it is like along single direction, its magnitude will be simply x. So and here it will be like y, so therefore you can write this vector a as xi plus yj. So okay. Okay, fine. So we have learned about unit vectors now. Actually, unit vectors are like very useful. Mm, Now let's see how we find out the magnitude of different vectors. So if we have a vector, let's say we have a force vector F is equal to 5i. So here I is basically representing, it is pointing, let's say if we have this as x coordinate, this as a y, then it is, this force is pointing towards x and it has magnitude of 5. So for like, for vector with only one term, the magnitude is simply this number. So if you have vector, let's say force is equal to a I, so here the magnitude of this vector so is a. Or if you have velocity vector, let's say velocity is equal to 10i, so or 10j, then also the 10 is the magnitude of this vector.
It's not.
Okay.
కూర్చోమ్మా ట్యాంక్ ఉంటుంది వాళ్ళది.
Okay, so now let's see like how we will find out the magnitude of other one. Okay, so
Excuse me, sir.
do you have any questions?
Yes, sir. Yes, yeah. How the magnitude would be a? It would not be root a or root 10 for magnitude.
mm, no, 1 second, 1 second. Okay, see if you have like uh okay, so if you have in definition of vector, in definition or in the representation, what we have learned is, if this is the vector, so this arrow is basically showing us the direction and the length of a vector is the magnitude of a vector. Okay, so
Yes.
okay, so now in case uh, you have mm, okay, let's say this is plus x direction, this is plus y direction. Okay, so in if you have a vector like you have this vector with length 10, and it is, since it is pointing in plus x direction, which is we are writing it as unit vector I. So let's say it was a force, so it was a force equal to 10 I. Okay,
Okay, fine.
one second, this pen is. So this length of this vector is basically the magnitude of this vector, right? So if you write it as f is equal to 10 I, then this part is basically showing the length of your vector, right? And this is the magnitude of your vector, because it is pointing in plus x direction. So there is no other component is present. There is a single component which is present here, and therefore this is itself a magnitude of this vector. Whereas if you see another case where okay, so now if you have a vector A, and let's say this is the it's this is the component of A along x-axis, this is component of A along y-axis, and this angle was theta. So since this is like x-axis, as you have studied from the properties of vector, you can move this y vector to here, and from Pythagoras theorem you can find out like the magnitude of A, since it is the hypotenuse of this triangle, like which is formed by from vector x, this is vector y,
Yes, sir, I
and
understood.
vector A. So in this case, the magnitude of this vector A is basically square root of x square plus y square. Okay.
Hmm. Okay, got it. Thank you. Thank you.
Okay. So now if you have similarly, if you have a vector, let's say vector B is I plus j, then its magnitude will be equal to root of 1 square plus 1 square, and it is root 2. Similarly, if you have vector B, which is 5i plus 10j, then its magnitude will be square root of 5 square plus 10 square, which is square root of 125. So now consider one more example like that, like let's say vector A, which is minus 10i plus 5 5j. So if this is the vector we are having, then also its magnitude A will be equal to square root of minus 10 whole square plus 5 whole square. So it is also root 125. So the only difference between this vector A and this vector B, both are having same magnitude, but their directions are different. So if we want to show it, So let's say this is plus x, this is plus y. So since both x and y, like for this vector b, the x component is positive, y component is also positive, and x component is lower than y component, so it is like this vector is like this. Okay, whereas in the vector a, x component is negative, y component is positive, and also here the magnitude of x component is 10, which is more. So this vector is like, here the vector b was like this because its y component is 10, its x component is 5, whereas the for vector a, the x component is minus 10 and y component is 5. So means vectors can have same magnitude but different direction also. So this is how you generally find out. Similarly, if you have a vector, let's say a bar is equal to xi plus yj plus zk. So in this case, its magnitude can be given as square root of x square plus y square plus z square. And so why this is so let's say one example of, let's take one example. Let's say you have vector a as 3i plus 4j plus 12k. Then its magnitude can be given as square root of 3 square plus 4 square plus 12 square. So it will be equal to root of 9 plus 16 plus 144, which is equal to square root of 169, and it is 13. So if you want to know like why in this 3D case, why it is like square root of x square plus y square plus z square, then you can find out it using simple geometry. Like let's say we have a cuboid, and you have a vector which is pointing from this point to this point. Let's say this is vector a, this is x, this is y, and this is z. Okay, so if you want to find out this length of this vector a, first of all what you will do is you will find this length, and then you will find this length. Basically you will find this length, then this length, sorry, first you will find this length, then this vertical length, and then using Pythagoras you can find a. So this length can be find out using x square plus y square root of x square plus z square. And since for a is basically square root of x square plus z square square plus y square, so it is x square plus y square plus z square. So you are applying Pythagoras theorem two times. First for this bottom triangle, which is in like bottommost plane of this cuboid, and then for this triangle. So by applying this Pythagoras theorem two times, you can arrive at the conclusion that magnitude of a is basically square root of x square plus y square plus z square. Okay, just give me 30 seconds. Just give me 1 minute, okay? In case you are having any doubt, you can type it in chat box. So mm, okay. So what we have learned in unit vector is, like, if we have a vector, let's say vector A is, let's say we have a vector A. So it can be we can write it as magnitude into unit vector. Okay, 1 second. So here, like here you can write vector A as the its magnitude and the unit vector. So here unit vector A is representing, means like generally we use ijk for x y z direction, it is general notations. However, here unit vector A is basically vector of unit length in the direction of vector A. Okay, here the unit vector A is uh, unit vector is basically vector of unit length in direction of vector A. Sorry, vector A. So generally, like when we write, let's say B is equal to 3i plus 5j. So it here I is showing unit vector in x direction, j is showing unit vector in y direction. So, but here in this equation, unit vector A is a unit vector of unit length in the direction of vector A. So if uh, if I give you vector, let's say vector A is I plus j, and I told you to find the vector of unit length in direction of vector A. So from this equation, like it is clear, that unit vector A is basically vector A divided by its magnitude. Okay, so if you have a vector A, we will find out its magnitude, which is equal to 1 square plus 1 square. So it is basically root 2. So unit vector A, or vector of unit length in A direction, is basically I plus j divided by root 2. So this is how you can find out the unit vector in any direction, in the direction of any given vector. So if we have let's say if we have B is equal to 2j plus 3k. So if we have to find out unit vector in in the direction of vector B, so the equation was like vector B can be written as its magnitude into unit vector in direction of B. So therefore this B can be given as vector B divided by its magnitude. Mm, okay, so vector B is given as its magnitude into unit vector in B direction. So this unit vector in the direction of vector B is can be given as vector B divided by its magnitude. So magnitude of vector B here is basically square root of 2 square plus 3 square. So it is square root of 13, and therefore unit vector in the direction of vector B, that is B cap, can be given as 2j plus 3k divided by root 13. I will try to type most of the things because this pen is showing some issues. Okay, so we will start with direction cosines now. So direction cosines are basically cosine of angle it made with the direction of three coordinate axes. So if you have certain vector, let's say if you have a vector A, and the direction cosine of this vector A are basically cosines of angle it makes with the positive direction of three coordinate axes. The direction cosines of a vector are the cosines of the angle it makes with the positive direction of coordinate axis. Direction of coordinate axis. Okay, so for example, let's say again we'll take a vector A. We have a vector A as x I cap plus x I cap mm, plus y mm, j cap. Okay, so let's consider this is a vector A which is x I cap and y j cap. So mm, we will draw it on the coordinate axis. Let's say this is positive y-axis, this is positive x-axis, and this is our vector A. Let's say this is vector A, this is positive x-axis, this is positive y-axis, and let's say this vector is making angle theta with positive x-axis. So again we will go to the Pythagoras theorem, like we will make the mm, right angle triangles. So if this angle is theta, so cos theta is basically, let's say this distance is x, this distance is y, and this magnitude is a. So basically cos theta here is x by a. Let's write this angle like theta as theta x. So here basically theta x is basically x upon a. Similarly, if you write this angle as theta y, then cos theta y is y upon a. So for this given vector a, these are its like cos theta x and cos theta y are its direction cosines. So these are basically angle made by this vector A with the positive direction of coordinates axis. So cosine of the angle made by this vector A with positive direction of coordinates axis. So if you consider 3D case, so in this case here there will have one more case like cos theta z, and that will be z upon a. So here a is basically magnitude of vector a. Okay, and x, y, and z are the magnitude of its component along x, y, z axis. So these are the direction cosines. So the definition, you can like easily understand it from its definition, like the direction cosines of vector are the cosine of angle it make with positive direction of coordinate axis. So let's take one example of direction cosines. Let's say we have a vector I plus j. Let's say we have vector A, which is I plus j. So I plus j means both I like both x and y components are same of equal magnitude and it is equal to 1. So if both are equal to 1, then the magnitude of vector A here will be root of 1 square plus 1 square. So it will be root 2. So if you find out direction cosine, so here the x magnitude of uh, x component is 1, magnitude of y component is also 1. So direction cosine cos theta x along x axis. So this is also equal, this will be equal to 1 upon root 2. Similarly, cos theta y will also be equal to 1 upon root 2, because this is basically x upon a, this is y upon a. So this is how we can find out direction cosines. So let's say you have one more vector b equal to 2i plus, or let's say 3i plus 4j plus 12k. So for this vector, the magnitude of the vector is square root of 3 square plus 4 square plus 12 square. If you solve it, you will get it as 13. So direction cosine of this vectors, the given vector b is theta x will be like 3 by 13, cos theta y will be 4 by 13, and cos theta z will be 12 by 13, because this 3 is its component along x-axis, or its magnitude along x-axis, magnitude of the component along y-axis, magnitude of component along z-axis, this 12. So this is how we can find out the direction cosines. Now we'll see two properties, like you have seen here. If they ask us to find out what should be the cos square theta x plus cos square theta y plus cos square theta z, like addition of the direction square of the direction cosines. So let's consider again one vector a with component ai plus bj plus ck. Okay, so in this case the magnitude of vector a will be square root of a square plus b square plus c square. So magnitude of its component along x-axis is a, magnitude of its component along y-axis is b, magnitude of its component along z-axis is c. So direction cosines cos theta x can be given as a upon square root of a square plus b square plus c square. So if you take the square of this term cos square theta x, it will give you a square divided by a square plus b square plus c square. Similarly, if you find out cos theta y, it is b upon square root of a square plus b square plus c square, and its square, basically cos square theta y is basically b square upon a square plus b square plus c square. Similarly, cos, you can find out for cos theta z. So I will just write down its square. So cos square of cos square theta z is basically c square divided by a square plus b square plus c square. So when you will add these three terms, it will give you a square plus b square plus c square divided by a square plus b square plus c square, and therefore it is equal to 1. So the answer for this is equal to 1. Similarly, if you ask, if someone asks you to find out same thing for sine square theta x, then you will simply write this cos square theta x as 1 minus sine square theta x. For y also you will write plus 1 minus sine square theta y. For cos square theta z also you can write plus 1 minus sine square theta z, and since it is equal to 1, this will be equal to like 1 plus 1 plus 1 3, and all this minus sine square theta x term will go on other side, and this 1 come on left side. So it will be equal, basically it will be equal to 2, like sine square theta x plus sine square theta y plus sine square theta z will be equal to 2. So in direction cosine, you should remember this thing, like theta x is the angle made by this vector a with positive x-axis. Theta y is angle made by a with positive y-axis. So this you should keep it in your mind. Do you have any questions in direction cosines? Please type, both of you. Okay, so now we will have 10 minutes break and we will meet at 6:40. Exactly at 6:40 we'll meet. You can have water or you can go to washroom and come back. Okay, both of you are there. Can you just type it? Yes, yes, Pujita. If we are able to finish the vectors today, then tomorrow we'll start with kinematics. Okay, so let's see how, like, if we have two vectors given, then how we add them. Like, let's say you have one vector A, it is given as I plus J plus K, and you have another vector B as 6I plus 2J plus 3K. So when we do addition, like when we add vector A with vector B, we will add like terms with I, means like we will add the uh, magnitude of vector with unit vector I to I, j to j, k to k. Like if we have so here when we are doing A plus B, we will add here, since there is magnitude is only one of this I unit vector, I plus 6 is 7I, then here we have 3j and 4k. Or if someone told us to subtract vector b from vector a, then we can write it as 1 minus 6 is minus 5i, then 1 minus 2 is minus j, and k minus 1 minus 3 is basically minus 2k. So this is how we do the addition or subtraction of given vectors. Like we add or subtract the corresponding terms only. So, or similarly, if I have a vector, let's say this vector A is I plus j plus k. So you can write 3a as 3i plus 3j plus 3k. Okay, I think this part is not difficult. So, so earlier we have like found out the resultant of vectors, and mostly we have used the what can we say, we have used Pythagoras theorem or trigonometry. Okay, so now we will learn about like parallelogram law of vector addition. Okay. Okay, so let's say we have two vectors, vector A and vector B, and we have to find out the resultant of these two vectors. So, and let's say the theta is the angle between these two vectors. So from the properties of these vectors, we have uh, learned that like we can move this vector uh, according to our need. Like in case if it is having same direction and magnitude, then it is the same vector only. So basically we will move vector a such that the tail of this vector A will match to the head of vector B. So here this is the head of vector B. So this point is head of vector B, and this point is the tail of vector A. Okay. And similar manner we can move this vector B. So here we got a parallelogram which has two sides, like two vector B, which is formed from mainly from two vector B and vector A. So in this case, the resultant of this vector A and vector B is basically the diagonal of uh, this diagonal of the given parallelogram. So this is basically the resultant of these two vectors. Okay, this, which is joining their initial point. So first what we have done is, since earlier initially we had two vectors, vector A and vector B, then we have moved them in a way so that we got a parallelogram, and now this diagonal of the parallelogram is known as the resultant of these two vectors, whereas the other diagonal is basically, see, this diagonal is a resultant and it is pointing in like in this direction, whereas mm, the other smaller diagonal, this diagonal is basically representing the difference in these two vectors. So the one thing what we have done here is we have connected, or we have matched the tail of vector A with head of vector B, and then the line which is joining this uh, vector from vector tail of vector B to head of vector A is basically our resultant. So okay, so this the second case I told, like if, one second, let's say if you have this case, so you have vector A, you have vector B. Now you have moved vector A such that tail of vector A is touching head of vector B. Then this, the closing vector, the vector which is originating from tail of B and reaching to the head of A, this vector is basically resultant of these two vectors. This is basically triangle law of vector addition. Triangle law, where R is basically A plus B. In this case also R is A plus B only, but here we will get, like we will use this parallelogram law to find out the magnitudes. So let's say first of all we got this parallelogram. Now I will make a bigger drawing so that it will be easier to grasp it. Hello. uh, uh, can you hear me? I think I lost the like. Hello. Just type, like, if you are able to hear me, just type yes. And like, was I connected for last 5 minutes, or I was disconnected? I am not sure. So last few minutes. Oh, disconnected. From which point? Can you just type from which point I got disconnected? Oh, okay. Just 3 seconds, then it's fine. Okay, no problem. So Vaibhav, you asked, I think, both 1D and 2D. So tomorrow we'll start with 1D kinematics, and 2D we will see it later. So okay. So, okay, so parallelogram law, what we have seen is the result. First of all, we had two vectors, A, vector A and B. Then we have moved them in such a way that we have formed a parallelogram, and the main diagonal of this parallelogram is basically the resultant of these two vectors. Okay, so this is how we have learned. And second thing, in triangle law, what we have done, we have moved vector, one of the vector you can move, like we have moved vector A in a way that it is touching tail of vector A is touching head of vector B, and then the vector which is closing this side, or the vector which is basically uh, closing, or which is originating from tail of B and touching head of A, is basically the resultant of these given two vectors. So we will see a bigger image or bigger diagram to understand the parallelogram law. Oh, sorry. I think okay. Again, I have to share the screen. Okay. So, so we got these two vectors, let's say vector A and vector B. Okay. So now we will make a parallelogram out of it. So, okay. So here we have vector B, here we have vector A, and this angle is theta. So from parallelogram law, we have learned that this is the this main diagonal, basically this is the resultant of the A and B. So let's draw some geometry. We will use, we will again use trigonometry. So So since this complete angle was theta, angle between A and B, this angle should also be a theta. Okay. So because this is vector A and this is like the angle between a vector A and B was theta, so therefore this angle is also theta. So from sine, like from trigonometric ratio, we know that this is basically A sine theta, this is A cos theta. Okay. Now from trigonometry, uh, let's say this resultant is making angle alpha with vector B. So tan alpha, or okay, tan alpha can be written as A sine theta, because this is opposite upon adjacent. So it should be equal to A sine theta divided by B plus A cos theta. Okay. So this is the angle of resultant with vector B. So this is alpha, and so tan alpha is basically A sine theta upon B plus A cos theta. Just give me a one, sorry for disturbance again and again. I'm getting one call, important call. I'm sorry. 1 second, just 1 second. Okay. So okay, so if if we have to find out the angle made by this resultant with B, then this is a tan alpha, and it is can be given as A sine theta divided by B plus A cos theta. Similarly, if we have to find resultant, like from Pythagoras theorem, we can write the hypotenuse, like square of hypotenuse is basically the square of A sine theta, like basically the square of adjacent and opposite side. So it will be like B plus A cos theta square plus square of A sine theta. So this is how we will find out the magnitude. So this R is basically root of, so here we will use A plus B the whole square. So it is B square plus 2AB cos theta plus A square cos square theta plus A square sine square theta. So R is basically square root of, see, here if we take A square common, then it is cos square theta plus sine square theta. So that is equal to 1. So this R can be written as A square plus B square plus 2AB cos theta. So this is how we can find the resultant of any two given vectors. Okay. So similarly, so this was the result. like method to find out the resultant. However, if we have to find out the difference between A and B, let's see. Let's take one more example. Mm. By the way, do you have you understand like how we got this resultant value of this resultant? Please say yes or no in chat box. Okay, thank you. So now like this was the resultant. However, how we will find the difference? So let's say again we have this parallelogram. So again early, so this was, let's say, vector A, this is vector B, this is basically we will call it as since it is pointing towards B, we can write it as B minus A. However, if the direction, if this arrow is in this direction, if this arrow is showing in this direction, then you will write it as A minus B. Okay. Okay. Sorry for the poor connection. I will share the screen again. Okay, so I will tell you what I was telling you again. So in this case, we have shown the direction of this arrow towards B, and therefore you can write it as B minus A. However, if you show this arrow towards this A, then you can write it as A minus B. Okay, so here we will just see the value and we will not go into the direction. Like we'll see how we can get this value. So let's say we'll call it as, let's say, some difference. Let's say we'll call it as D. Okay, then we will again make a triangle. We know this angle was theta. So this is A sine theta, this is A cos theta, this is already B. So this D, if we make this, consider this right angle triangle, if we consider this right angle triangle, then D square is basically A square sine square theta plus B minus A cos theta whole square. So it will be basically A square sine square theta plus B square minus 2AB cos theta plus A square uh, cos square theta. So again, this A square cos square theta, A square sin square theta will give A square. So D square we will get it as A square plus B square minus 2AB cos theta. So this is how you can, this is square root of A square plus B square minus 2AB cos theta. So here D is basically difference between these two vectors. Like either it can be A minus B or it can be B minus A. So okay, and this is how it is. Whereas if you have to find out resultant of these two, then you can find it as a square plus b square plus 2ab cos theta. So you can solve any kind of example using this. Like if someone gives you two vectors, let's say, mm, okay, so let's say you have a equal to I plus j and b is equal to 4i plus 2j. 4i plus 2j. So its resultant, if you have to find out its resultant, and so first of all, uh, here, like if we have to find out the direction, like angle of a with respect to x, positive x axis, then mm, it can be basically find out at tan inverse of y upon a. Okay. mm, 1 second, we will take some easier example because it will make the complication, like calculation, very complicated. Mm, okay, so let's say you have vector a which is I plus j. Okay, so it is I plus j means you can simply draw it as this is 1, this is 1, both magnitudes are 1. So if you have find this theta, it will become like tan inverse of opposite upon hypotenuse. So it is 1 tan inverse of 1. So tan inverse of 1 is basically 45 degree. So this angle is 45 degree. Similarly, if you have vector b, let's say the vector vector b is root 3 I plus j. So root 3 I plus j is basically uh, root 3 is 1.732, so it will be somewhere here, and j is 1. So let's say this is your vector b. Okay, so the angle, like angle of this angle, basically if you have to find out, it will be tan inverse of mhm, okay, or will tan inverse of 1 by root 3. So tan inverse of 1 by root 3 is 30 degree. So A is making angle 45 with x-axis. B is making angle 30 degree with this x-axis. So the difference, like the angle between A and B is 15 degree. Okay. Angle between A and B is 15 degree. So if we have to find out the magnitude of resultant between A and B, so how we can find it out is, let's say resultant is R, so its magnitude is basically root of A square plus B square plus 2ab cos theta. So where A is basically, so the magnitude of A is basically root 2, because it is 1 square plus 1 square, it is root 2. then magnitude of b is square root of root 3 square plus 1 square. So it is, so magnitude of b is basically root 3 square plus 1 square. So it is 2. So magnitude of A is root 2, magnitude of B is 2. So and their angle between them is 15 degree. So the magnitude of resultant can be easily find it as root 2 square plus 2 square plus 2 into root 2 into 2 into cos 15 degree. So this is how you can find out the magnitude of the resultant. Whereas if you have to find out the angle made by resultant with x-axis, so for finding out this angle, you can again you can use this formula where it is magnitude of a into sine theta divided by b plus a cos theta. However, since in this case b is not like so the magnitude of like resultant of r like magnitude of resultant you have find out using same formula and it is correct. But if you have to find out the angle, we will check it. Okay, we'll draw it. Okay, so one easy thing what you can do is, right, the resultant was correct. So second thing you can so in this case if you someone asks what is the angle this resultant, so resultant will be like somewhere in between. So if someone asks what is the angle resultant is making with x-axis, like what is this theta r, theta of resultant. So what you can do is you can make this vector b horizontal. So if you make this vector b horizontal, then vector b a will be like at 15 degree from vector b. Okay, if you make it horizontal, then you will find out the angle alpha made by basically it is the angle made by resultant with vector b. Okay, so first of all you find out this alpha angle using this same formula, a sine theta upon b plus a cos theta. After getting this alpha, you can add the angle of like theta b, so it will give you the angle made by resultant with the horizontal or x-axis. So you can use or you can solve it like that. I think this was slightly difficult, so if you have any question in it, please tell, like if you want me to repeat this how we have found out the angle of resultant from horizontal, or if you have understood, just type yes. Okay, so I think both of you have understood. So that alpha was basically the angle made by resultant with respect to vector b. So we have just added alpha to the angle of theta, so we got the angle of resultant from horizontal. So here we have seen like both law of like how the parallelogram of vector addition, and then we have seen triangle law of vector addition. Similarly, there is polygon law of vector addition. So it is like polygon law of vector addition is like if you have first vector, then you have second vector, then you have third vector. Let's say this is your fourth vector. So if this is forming like this is A, B, C, D. So the vector which you are using to closing this polygon, let's say this, which will start from head of D and ending at tail of A. Let's say so this is basically resultant of all four vector, and this resultant can be simply given as A plus B plus C plus D. So this is polygon law of vector addition. And just if you have to find out the resultant of vector which are arranged in a way like head of one vector is touching tail of another vector, then you can simply find out their resultant like this. Okay. Okay, now we will see the dot product and cross product. So first, let's see dot product. So dot product is also known as scalar product. So if you have two vector like A and vector B, then their dot product is represented as A dot B, and its value is equal to mod A. Mod A basically magnitude of A into magnitude of B into cos theta. So this is how we calculate the dot product. So few things you should notice, like dot product of unit vector is equal to 1. Or sorry, I forgot to mention, dot product of unit vector in same direction is equal to 1. Whereas if you take the dot product of two unit vector which are perpendicular to each other, let's say I dot j, then it is 0, or j dot k, then it is also 0, or k dot I, then it is also 0. Why it is 0? See, dot product is magnitude into like magnitude of A, magnitude of B into cos theta. See if you are putting here I, both A and B as I, so magnitude of A is 1, magnitude of B is 1, so 1 into 1 is 1. And since they are parallel to each other, or like they are it means they are in same direction, unit vector in same direction, therefore basically theta is 0 degree. Okay, so theta is 0, therefore the whole term will become 1. But in when you are trying to get dot product of two perpendicular vector like I and j, so here cos theta will be 90 degree, so cos 90 is 0, so therefore I dot j is 0. So if I give you vector like let's say A is 2i plus j and B is 3i plus 4j, then A dot B, here basically you will multiply the I term with I and j term with j. So 2i into 3, so I into I is like equal to 1, and 2 into 3 is 6, plus j into j is also 1, so 1 into 4 is 4, and you get some scalar value. Okay, so the output of dot product is some scalar value. So here you got IA, which was 2I plus j, B, which was 3I plus 4k. Their dot product A dot B is equal to 10. Let's find out the magnitude of A. So magnitude of A was root of 2 square plus 1 square. So it is 4 plus root 5. Okay. Similarly, magnitude of B, if you find out, it is root of 3 square plus 4 square. So it is 5. Okay. Because root 25 is 5. So here we have learned like dot product of two vectors is a dot b cos theta. So if someone tells you to find out angle between a and b, so you know their like dot product was 10. So 10 is equal to magnitude of a is root 5, magnitude of b is 5 into cos theta. So here theta will be equal to cos inverse of, here it will be 2, so 2 upon root 5. So this is the value theta. So you can like in question they can ask you to find out angle between two vectors. So what you can do is that you can first find out their dot product, like I into I, like here 2I into 3I is basically 6 and I dot I is 1, so it is 6, and j into 4j is basically 4. So you got their dot product, then you got their individual magnitude, and using this relation you can find out their angle between these two. Okay. The next thing is uh, cross product, or we can say it as generally we can call it as vector product. Okay. So let's say cross, that was dot product. So it is cross product, and it is also called as a vector product. Let's say y. Let's see y. So if you have vector A and you have vector B, so their cross product is basically given as A cross B is equal to mod A, that is magnitude of A, into mod B, that is magnitude of B, into sine theta. Here I forgot to told you one thing, like why it is like significant. So when we find out the work, so work is basically dot product of force into displacement. Okay, it is dot product of force into displacement, and work is basically you will get some scalar value, some scalar here. Okay, so if I'm like, if you have a body, you are applying 5 Newton force and it has displaced by 5 meter in this direction, like 5 meters it has displaced, then work can be given as, here force it is in, let's say this is x direction, which is represented by unit vector I, so force is 5I, displacement here which is given as, sorry, this was force, okay, s is given as 5I because it is also in x direction, then work is basically 25 joules. Here let's say unit was Newton, here unit was meter. Okay, so this is how you can find out the work done. Whereas you are applying, let's say one same body you are taking, you are applying force of 5 Newton in this direction, and your body like of 10 Newton, and you are so if we are considering this as uh, y direction, then we can write force is equal to minus 10 j, let's say Newton, because minus, because it is in like negative y direction, and this body has moved by 5 meter in plus x direction, so s is again plus 5. So some, if someone tells you find the work done by this force of minus 10 Newton in downward direction, so here work will be for dot product of force into displacement. So it will be dot product of 10j dot 5I. So as you know that j and I are perpendicular, their dot product will be 0. So therefore, work done by this vertical force on this body will be 0, because movement is taking place in horizontal direction or x direction. So this is how it is important. Okay. Similarly, now we can see the cross product. So cross product is given as a cross b as a cross. So if you have, let's say, vector a, which can be given as ai plus bj plus, oh, okay. Mm, let's say you have vector a, which can be given as a1i plus a2j plus a3k, and if you have vector b, which is given as b1i plus b2j plus b3k, so their cross product a cross b can be given as I determinant of I j k a1 a2 a3 b1 b2 b3. So their determinant can be like, we will solve the determinant as, first we'll take I outside. Okay, when we are taking I, we will skip this row, sorry, this ijk row, complete row, and this column where, and then we will take a2 into b3, a2 b3 minus a3 into b2. Then we will write minus j into, now we will skip this column, and so we can write as a1 into b3 minus a3 into b1 plus k into, now we will skip this column a3 b3 column, so we can write a1 b2 minus a2 b1. So this is how we will find out the determinant of this matrix, sorry, determinant of this scalar, sorry, vector product or cross product. So you can see that the final answer of this cross product is basically a vector, and therefore it is known as vector product. Okay, so first thing you should notice, like we have written here a cross b, but a cross b may not, means not, it is not necessary that it is equal to b cross a, means it can be different, so you should keep it in your mind. So if you have to find b cross a, then it will be, similarly you can write I j k, but first you will write b1 b2 b3 a1 a2 a3, and then you can find the determinants in similar manner. Okay, so this is how we find out the cross product. So it is useful in angular velocity. So angular velocity is basically written as cross product of linear velocity into uh, radius vector. So this is how you calculate the angular velocity. So let's take one example of this cross products. So if you have a vector, let's say a as 2i plus 3j plus 4k, and vector b as I plus j plus k, then a cross b can be given as I j k 2 3 4 1 1 1. So you will find out its determinant, so you will get I into this 3 into 1 minus 4 into 1, 3 into 1 minus 4 into 1 minus j into 2 into 1 minus 4 into 1 plus k into 2 into 1 minus 3 into 1. So it gives you 3 minus 4 is minus I. Then 2 minus 4 is minus 2. So minus 2 into minus j is plus 2j plus, sorry, 2 minus 3 is minus 1. So minus k. So this is the A cross B you have got. So the magnitude of A cross B will be root of 1 square plus 4, sorry, 2 square, 1 square plus root of minus 1 square plus 2 square and plus minus 1 square. So it is 1 plus 4 plus 1, like it will be root 6. And if you find out the individual magnitude, then it will be uh, square root of 2 square plus 3 square plus 4 square, which is root 29. And here square root of 1 square plus 1 square plus 1 square, so it is root 3. So then you can use this formula. So here this is basically the magnitude of A cross B vector. So from this formula you can find out the angle between these two vectors. So sine theta is basically A cross B divided by A B. So it will be basically root 6 divided by root 29 into root 3. Okay, just give me 1 minute.
Yes.
Oh, sorry, I forgot to turn on my audio. I'm sorry. Okay, so what I was telling is, in dot product the output is scalar, whereas in cross product the output is a vector. So since it, let's say earlier we have like there was vector A, then there was vector B. Both were having some directions. Okay, so the directions of uh, the cross product, like their cross product A cross B, we have A was there having some direction, B was there having some direction. So direction of A cross B will be, what you should do is, uh, take your, let's say if you have vector A in this direction, vector B in this direction. So take your right hand and like point it towards direction of A, okay, and then start rotating it towards B. So when you start, like, take your right hand, point it towards, like, all four finger of this right hand towards vector A. Then when you will start turning that fingers towards point B, then the direction, then the direction of your thumb will show the direction of A cross B. So here in this case, the direction of A cross B will be like this, because if you take your right hand fingers and it starting to turn towards B, then your thumb will point towards this direction. So this will be the direction of A cross B, and this direction is perpendicular to both A as well as B. In similar case, if you find out B cross A, so in this case, first of all, you will point your fingers, all four fingers towards B, and then you will rotate to it towards A. So if you find out B cross A, so it will be towards, like, opposite direction to the A cross B. So this is, you should like always keep this in your mind, like their directions are like very important. So now we are remain with the, like, we'll just see like what are the different types of vectors which are possible. So like if two vector, when we will see two vectors are equal, when they will have, like, first we will write equal vectors, equal vectors. So vectors are equal when they will have same magnitude. So here magnitude is basically shown by their length. So here both A and B are having same magnitude and they are pointing towards same direction. So therefore vector A and B are equal. So similarly, if you if you make a vector which is exactly opposite to vector A in reverse direction, so this will, we can write it as negative vector, because only the direction is different, sorry, direction is exactly opposite to A and magnitude is same, so you can write it as negative vector, or you can call it as negative or opposite vector basically. Okay, similarly if two vectors are parallel, you can call them as parallel vectors. Then they are parallel but pointing in opposite direction, then they are called as anti-parallel vectors. So these are parallel and these are anti-parallel. Then if two vectors are perpendicular to each other, then they are called as orthogonal vectors. Then if two vectors have same initial point, like their tails are matching or starting from same point, then we call them as co-initial vector. Or if two vectors are in same line, they are called as collinear vector. If two, let's say if you have xy plane, x y, and if you have two vectors in same plane, then they are called as coplanar vectors. So if you consider, if there are only two vectors, then they are always coplanar, means there is at least one plane where both the vectors are present. So when two vectors are present, they are always coplanar. Then if the vectors are passing through same point, like this multiple vector passing through same point, then they are called as concurrent vector. So unit vector you have already studied, and if a vector has zero magnitude, so it is basically zero vector. Zero vector is basically zero magnitude. So this classification, I don't think it is that much useful. So now we will see some questions like which are important or which came in the previous class. So first one is the vector p is let's say it is given as ai plus aj minus 3k. I will write right now. Vector p is ai plus aj plus 3k, and vector q is ai minus 2j minus k. They are perpendicular to each other, so therefore find out the value of positive value of a. Okay, they are asking us to find out positive value of a. So we'll solve this. So you have vector p which is ai plus aj plus 3k, and vector q which is ai minus 2j ai minus 2j minus k. So they are telling these vectors are perpendicular to each other. So when vectors are perpendicular to each other, their cross product must be zero, because dot product, dot product must be zero, because dot product of two vectors p dot q is basically mod p mod q cos theta. So when vectors are perpendicular, cos 90 will be 0. So dot product of two vectors is 0. So dot product of p and q is 0, which is equal to, here we have both the item has a, so it will be like a square, then there is plus a and minus 2, so minus 2a, and 3 plus 3 and minus 1, so it is minus 3. So you can factorize it like a minus 3a plus a minus 3. So you can get a minus 3 plus 1 into a minus 3. So a is either equal to 3 or a is either equal to minus 1. So positive value of a is basically 3. So here the correct answer is 1, which is 3. Means option 1 is correct answer, which is 3. Okay. Let's come to the second question. So the vector a, b are such that a plus b is equal to a minus b. Okay. Mod of a plus b, sorry, mod of a plus b is equal to mod of a minus b. The angle between a and b is, okay. So when, if I give you any two vector, let's say you have vector a and you have vector b, and again you have vector a and you have vector minus b. So the resultant of first two magnitude of, so as what they have given is their magnitudes, like mod of a plus b is same as mod of a minus b. So what is mod of a plus b? Let's find out. So it is basically, for a plus b, it is a square plus b square plus 2ab cos theta. And for Similarly, for a and minus b, it is basically uh, uh, their magnitude is basically square root of a square plus minus b square plus 2 into a into minus b cos theta. So after solving that, we will get it as a square plus b square plus 2ab cos theta. So since both are equal, we will equate them together. So it is a square plus minus b square is b square minus 2ab cos theta. So a square plus b square got cancelled. So 2ab equal to minus 2ab. So this is which is basically telling us 4ab cos theta is equal to 0. So since both a and b are not like, so it is basically telling cos theta is equal to 0. Either a b can be 0 or cos theta can be 0. So for cos theta equal to 0, theta will be equal to 90 degree. So this is how you can find out the value, like answer for second question. So here the correct answer was 3. Here the correct answer was 90 degree. So let's say the third is two vectors of equal magnitude have resultant equal to either of them in magnitude. So find out the angle between them. So again, see, same uh, formula can give you multiple answer. So resultant, so let's say first is having magnitude a, second vector is first vector is having magnitude a, second vector is also having magnitude a, and resultant is also having magnitude equal to either of them. So two vectors of equal magnitude have resultant equal to either of them in magnitude. So either of them means it is also a. So basically you can use same formula. So here resultant is also a, is square root of a square plus a square plus 2a square cos theta. So it is basically taking square on both sides. A square will be equal to, here we will again take 2a square common, so we will get 1 plus cos theta. So 2, okay, 1 plus cos theta is equal to 1 by 2. So cos theta is equal to minus 1 by 2. Okay, so let's check the options. So if cos 60 is what? Cos 60 is 1 by 2, so it cannot be the answer. Then cos 90 is 0, it cannot be the answer. So cos 30 is basically, sorry, one, I think I made one mistake. Okay, cos 60 is 1 by 2. Okay, but we have cos theta is minus 1 by 2, so it cannot be the answer. So from trigonometric relation, mm, so let's say cos a plus b. We know from our first class cos a plus b is cos a cos b minus sin a sin b. So first thing is cos theta is minus 0.5, so or minus 1 by 2. So if you remember the chart, you can simply find out that theta is 120 for this. If you don't remember the cos 120, you can simply write cos a plus b as cos a cos b sin a sin minus sin a sin b. So for cos 120, you can write it as cos 90 plus 30. So it will be equal to cos 90 cos 30 minus sin 90 sin 30. So cos 90 is 0. So this term will get cancelled. Sin 90 is minus basically 1. So it will be minus into sin 90 is 1 into sin 30 is 1 by 2. So it will be minus 1 by 2. So cos 90 plus 20 is cos 120 is basically minus 1 by 2. You can easily find out using these formulas. So the answer for this question is 120 degree. Fourth one is a force 3I plus 4J Newton acts on a body and displaces it by SI. So I told you work done is dot product of F into S. So you can simply write 3 into 3 plus 4 into 4. So it will be 16 plus 9 is 25 joule. Then a vector sum of two forces is perpendicular to their vector difference in that case. So vector sum of two forces, vector sum of two forces is perpendicular to their vector difference. Okay, so in that case forces. Okay, okay. So again it is the question of resultant only. Okay, so vector sum of two forces is basically the resultant. So it is like if you find out the addition, like a square plus b square plus 2ab cos theta, and okay, and their difference is basically given as r square as a square plus b square plus 2a minus, sorry, minus 2ab cos theta. Okay, so this is vector sum and this is vector difference. Okay, so we'll go to the question again. The vector sum of two forces is perpendicular to their vector difference. So in that case the forces, so actually if you see the case of rectangle or square, so let's say this is a square. So in you have vector a in square, all sides are equal. So this is vector a, this is vector a. So here the resultant of these two vector is basically root 2a, and if you take the difference between these two vector, it is also root 2a, and these two are perpendicular to each other. Because in square the diagonals are perpendicular to each other. So the I think the answer should be like, means this is the special case like of for the square where the uh, angles like where since both sides are equal for square, the vector sum, which is the resultant, and vector difference both are perpendicular to each other. Okay, so in this case what we have found out like both vectors are equals. Okay, so this is the first case. Now consider the case of rectangle. So in the rectangle, like when forces are unequal, so let's say this is was or forces or these vectors were unequal, then in this case their like resultant and their difference is not equal. So here the answer should be like when forces are equal to each other. In this case it is possible that uh, their difference as well as their sum are perpendicular to each other. And this is there is one more special case for this, which is a rhombus. So in rhombus also, all since all sides are equal, the angle between these two is equal to 90 degree, and means the resultant as well as the difference between these two vectors is perpendicular to each other. And if you have to prove that, basically you what you will have to do is uh, you will have to use trigonometry, and with trigonometry you can simply solve that. So this coming to the sixth question, the direction of angular velocity vector is along. So if you consider a circular motion, if you consider a circle, okay, so at this point, let's say radius vector is in this direction, linear velocity is in this direction. So since angular velocity is cross product of linear velocity and radius vector, so if you point out your fingers in the direction of velocity, linear velocity vector, and if you try to move it towards the radius vector, so 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 this angular velocity will be perpendicular to both radius as well as velocity vector. So it cannot be like first three option, if you see, they are in plane with radius or velocity vector. And since this omega is perpendicular to both v and r, it should be the axis of it should be the axis along the axis of rotation. Okay, coming to the seventh question, if a vector 2i 3j plus 8k is perpendicular to vector 4j minus 4i plus alpha k, then the value of alpha is. So since they are perpendicular, their dot product should be 0. So we will multiply I term with I, because for dot product we do like that. So 2i into minus 4i, so it is minus 8. Then 3j into 4j, it is like plus 12. Then 8k into alpha k, so 8 alpha, so it is 0. So 4 plus, so alpha is equal to basically minus half. Again, coming to the last question, so that is, if a cross b is root 3 ab, then value of a plus b. So here a cross b is root 3 a dot b. So what is the magnitude of a cross b? It is magnitude of a, magnitude of b into sine theta. Then it is root 3 times dot product of ab. Dot product of ab is magnitude of a, magnitude of b into cos theta. So this a, b, a magnitude of a and magnitude of b will get cancelled. So sine theta by cos theta is tan theta is basically root 3. Tan theta is root 3 means theta is equal to 60 degree. Okay, so this is the angle between them. So if you have to find the resultant of a plus b, it is a square root of a square plus b square plus 2ab cos theta, and it is theta is 60, so cos 60. Cos 60 is 1 by 2. So one here, if you put 1 by 2, 2 will get cancelled with 2. So the final answer is square root of a square plus b square plus ab. So so we will stop here. Thank you so much for joining. So I will share you all these questions, you can solve it, and if you have any questions or doubt, you can ask me. Okay, I will give you more number of questions to solve. Okay, we'll meet tomorrow. Bye. I will end this meeting.